most of the hard part is done once you have it on your computer and the drivers are there. That's like, I mean, yeah, the hardest part. Yeah. So you're basically done now. The rest is just playing. So what we're going to be doing is playing with these electronic bricks. So they call themselves, or the company calls these, to try to get an idea of, like, the brick being this one little unit that you can put into a whole system, which you guys probably know a lot more about than I do. Basically using it as a constructed element that you can build all kinds of different things with, and the actual unit itself doesn't restrict what you're going to make. And it comes with a number of inputs and outputs, sensors, lights, a screen that you can bring text to, all kinds of different things. And as we work through the kit handout, which if anybody doesn't have one, just put your hand up. There's a few more down here. It's good to take notes on and whatnot. And that's what's on the screen here, so I'm going to work through the whole thing with you. So what you're going to want to have up on your screen before we begin is, you have this physically, so you don't need to have that on your screen, but you're going to want to have the Arduino environment up and running. You won't necessarily have code on yet, but you're going to want to have the environment open. So anybody who can't put out one of their hands and touch one of the bricks, put up their hand. Because you should be able, two of you, to grab one right next to you. You should have an Arduino. You should have a cable. Talk to that Arduino. And the brick. If anybody doesn't have that, raise your hand right now. Good. Okay, cool. All right. So the purpose of today is to get you guys familiar with programming Arduinos. And the main reason we want to use these bricks is that other than plugging in some cables, you don't have to do any electronics, you don't have to know any electronics, you don't have to know what a resistor is or an LED or any of that stuff. You just plug things in and then work with them in software. You don't have to actually know how to play with them. Alright? So if you've got the drivers and you're all ready to go, the very first test is to open up your environment. So I'll just call it like the Arduino IDE, Integrated Development Environment, or just the environment. One of the things that's confusing about Arduino is that they call the boards Arduino and the software Arduino, and the type of code you write is in the language Arduino. So it's very, very confusing. Most other people will have different names for everything, but they want everything to be kind of standardized. So they do it. So we have this environment open, and that's really hard to see. It's a little brighter here. So this is the environment. Can everybody see that? It's not too difficult, but weird way. So basically, that's so good. So effectively, there's a few things that you're going to need to use. If you go up to Tools, and you come down to Board or Serial Port, that's where you're going to select what you're actually going to plug into. The board that you should all be using, unless you know otherwise, is the Arduino Duo, which is the second one on the list. If you physically look on your Arduino, it'll say exactly what kind of Arduino it is. So pick whichever one it is. You may have an Uno, depending on who's working with it. In terms of the software, there will be no difference. The pinout is all the same. Mainly the only thing with the Uno, which is the newest one, is that you don't have to install those drivers. That's pretty much the main, other than a few kind of random electronic changes they made, that's pretty much the only changes that matter when you're writing code for it. And then in serial port, you're going to have to pick which port you're actually going to be using to talk to the board. So generally, any given cable will identify itself always as the same port. So on a PC, it'll say COM5 or COM12 or COM something. On a Mac, it'll identify as TTY something. It'll be like a string of numbers and letters. It might say USB in there somewhere. So once you've identified it and found it, then pick one. And I'll just pick the top three, because I don't have a board for that. It should be the only one that has a TTY. If you have more than one, then pick one, and then we'll do the next step, and if it doesn't work, then pick another. Usually when I'm at work at the studio, I have about 8. So I physically label all of the cables with the numbers that the computer thinks they are, so I can just pick them on the list based on what I've taken on to all the cables. And then what you're going to want to do, across here is kind of the things that you do all the time, up in the top here. So this one up here is to run, to verify that your code will actually build and work. You haven't done a typo or something like that. First button. The second one is going to be upload, when you actually want to put the code onto the board. The third one here, which looks like a sheet of paper, is just to start a new sketch. So they call kind of a chunk of code is a sketch for these guys. And then open and save. Up is open, down is save. And then way over here, there's the serial monitor, which we'll get to in lesson 7, I think, 6 or 7, something like that, of the 8 that we're going to do today. So right now, I want you to open. And you won't have all of this, because this is all my stuff, but you will have 1, 2, 3, 4, 5, 6, etc. You just go to Basics and Blink. Click that, we'll open it. And if you have an Arduino plugged in, and the label down here, you can see that, the way down at the bottom, it'll say what kind of board you're talking to, and what port you're using. So if that looks right, then you can hit upload, which is the right arrow here. It's in the open menu. And I'm fairly certain at least 90% of those have an associated tutorial on the Arduino website. So if you see something that you're interested in, you're like, oh, I want to do whatever that is. If you go to the Arduino website, it's almost guaranteed that there will be some kind of tutorial so that you can actually hook it up with your own electronics if you want to buy a kit, more like what Philip brought, where it's just a whole bunch of parts and you're putting it together. Because once you have this core understanding of the programming side of it, then it's good to kind of introduce yourself to a little bit of the electronic side of it as well. So different parts and putting them together. Philip's got a breadboard in front of him here, which is a very standard kind of prototyping tool for doing really basic electronics. And even some like hardcore electronics people swear by just having a whole table of breadboards and just like plugging the whole thing together. Very, very handy. But with the Arduino, today at least, we're going to work on the programming side so that you don't have to worry about that when you're dealing with all the interesting issues that come up when you're trying to do the electronics side of it. Yeah. Okay, so who wasn't able to upload Blink code to their device? Good? Solid? All right. So you grab your workshop booklet. The booklet was produced by the people who made these bricks. So they know intimately more details of the bricks than I do, for sure. It should tell you what all the different parts are and all that kind of jazz. Treat the first, I think it's about 5 or 6 pages, 10 pages apparently, as a reference. So it'll tell you what the different parts do, how to use them, why they've done this, some of the introduction that I've given you about how to use Arduinos, why you would use them, that kind of stuff. Their website also, I think these are made by Seed Studios. They're also sold by Make magazine, the Maker Shed, which is associated with the magazine. So there's all kinds of different versions of this. There's different types of things. And you can buy all kinds of different shields, which is basically just anything that you can plug onto the top of an Arduino that will do something predefined. So you can get a shield that has an Ethernet port on it, or you can get a shield that has Wi-Fi, or you can get a shield that will run motors, or whatever. This one is very much just basically a breakout, so it's just taking all of the pins that it connects to the Arduino and turning them into a bunch of different plugs that plug stuff in. So, once you've had a little bit of a glance through that intro stuff, then feel free to give me shouts if you have any questions about any of that stuff, just as kind of very brief introductions to the bits and pieces that are in the kits. And then we can get started with lesson 1, which will be basically it will teach you guys what digital inputs and digital outputs are. If you already know what those are, and you're a very fast reader, feel free to start on lesson 1. And yell out any questions if you have them. I'm not a fan of being quiet workshops, so feel free. And if you have any questions about the stuff before lesson 1 starts, feel free to just yell out, because if you've got a question, someone else in the room probably also has the same question.
If you can just take a couple of minutes to give an overview of what we're looking at here.
Of course.
Just to kind of spatially orient. Here's a device. These are the different parts of it.
Sure. Yeah, so basically, guys, and I think there is, it might be like page 3 or 4. No, it's just got a picture of it. Yeah, there we go. So page 2, the introduction. It's talking about when you would use this board, how you would use it, why you would use the board. It doesn't really talk about what the board is. There is a fairly detailed kind of introduction to Arduino. There's books, there's all kinds of different stuff, there's some on the website. But I can definitely give you a very brief kind of hardware rundown. And potentially, there might be a blown up. So you've all got one of these boards. Obviously, you've identified the USB port because you're using it already. The other big flat plug on there is just a standard like DC barrel plug. So the same as what your computer would use for power or anything like that. You can get, I think you can plug these in anything from 7 to 10 volts or 7 to 12 volts, something like that. Usually you just get like a 9-volt adapter because that's the most common type of, we call them wall warts, but like the big, ugly, gross things that plug into the wall and then cable coming out. One of those, plug it in, and then you don't need a computer involved. You can just plug it into the wall, and there's a little bit of a power system in the same corner as that plug that converts it into the clean power that the chip actually needs to do everything it wants to do. Other than what's up in that top corner, which is almost all power and electronics, the chip that's down beside the USB port is an FTDI chip. That chip is the reason, on the Duino anyways, that chip is the reason that you had to get drivers, because it converts the USB signal into something that the chip can understand. That's this one here. On an Arduino, it's different. On an Arduino, they have a chip which will do the actual USB, because the main brains, the microcontroller, which is the big chip, can actually talk using the USB protocol, so it doesn't actually need to have a translator in between, basically.
FTDI means something digital.
Yeah, it's the company's name. I think I think it's like 2 of the founders' digital inputs. And then most of the rest of the space is just dedicated to wires going back and forth. There's a big button, which is or not a big button, but there's a push button, which is just the reset. So if you, for any reason, want to restart your code right from the beginning, you can just hit that button, and it'll be as if the board is just plugged in.
Maybe we should just mention that, unlike computers where you've been taught to be very respectful of their turning on and off because of hard drive recompiling so on. This is such a dumb machine that you can happily unplug, plug back in, reset without worry.
Yeah, there's no moving parts, there's no, like, it's all, basically this has all the advantages of if your computer had all the latest flash memory, flash everything, so that if you unplugged it and plugged it back in, it would just start up from scratch again. The main reason that most computers need all that time is because there's the super complicated software running on it, and there's all the little bits and pieces moving parts for hard drives and CD drives and all that kind of jazz. So yeah, you can very happily unplug this, replug it, hit reset 100 times, it doesn't care. And then other than just the connectors, so you can get access to the pins of the microcontroller, the big chip here is, I think they usually use an Atmega 328, yeah. Unless you're on an Uno, and it's a slightly different Atmega chip, just because it includes the USB stuff on board. So I think it's an Atmega 328 UP something. And basically that chip runs at a certain speed based on the little crystal that's on the board, which is a little metal can on these Arduino Noves. And there might be, there's probably another little metal can on the Uno as well. And basically what that does is, it's a crystal, and if you give it power, the crystal will just flip back and forth at a set speed. So that is what the chip will actually use as a clock, so that it knows how fast it should be running. And so that it has a good sense of real time, so like how many seconds have passed after something. And other than that, this microcontroller here, this chip, has memory on board, it has RAM, it has the processor, it has analog to digital converters, so you can get, and we'll get into what the differences are between analog and digital, but it has converters in it, because most logic within an actual computer is digital, and if you want to actually use sensors and stuff, usually you have to live in the analog, and it's kind of two separate realms. It's like the differences between using integers and real numbers. Basically, if you can have like a decimal of some kind, that's analog, or if you just have like 1, 2, 3, that's digital. And in this case, because of how these work, digital is just 0 or 1, or on or off, or true or false, or whatever. And we'll get into that in the first lesson. And I think that's it on these boards. And they're very proud that they're made in Italy, so there's a picture of Italy on that.
Just the first take on what things are in terms of power, sensors, actuators, and just so that you can read that and understand
what all the text means.
Those global functions. I don't mean in detail.
So if you're going to plug a shield into this, it'll just plug into these two banks of headers. The flat pins, either the, I guess the male and female versions of headers, they're both called headers. Basically when you plug in, it's going to actually connect all those pins to places on the microchip, on the microcontroller here. So the numbering that you've got across the top, from 0 up to 13, that's not 31 and 21, so they kind of wrote it here. But it's 10, 11, 12, 13. And then a ground and an analog reference. Those are your digital outputs, which is why it has a little digital name on there. And basically those are the inputs and outputs that you would use with standard, like a button or an LED or anything like that you want to just do on, off, up, down, 1, 0, that kind of logic with. And a couple of them have special callouts. There's a TX and an RX, right on the 0 and the 1.